Hello dear students, welcome to this video on measurement in physics. Let's start with this question. What is measurement? In physics, we use various quantities to describe the world around us, such as length, mass, and time. Measurement is the process of determining the value of these quantities. This is essential because these values are used in mathematical equations to predict the behavior of different systems and objects. For any measurement process, we need to consider three key aspects: the tools which are used to perform the measurement, the units which identify the outcome of the measurement, and the technique which describes how to properly use the tools to achieve the most accurate results. Now, let's focus on the measurement process by considering length. To get a deeper understanding, let's start by asking, which tools do we use to measure length? In fact, we can use various tools such as rulers, measuring tapes, calipers, and many others as shown here. The selection of suitable tools depends on the purpose of the measurement and the required level of precision. Now, let's ask, how do we express measurements? In fact, we use units such as millimeters, centimeters, meters, or kilometers. The choice of unit depends on the length being measured. For example, we use centimeters to measure a piece of paper, meters for dimension of a house, and kilometers for the distance between two cities, and so on. Now, what about the technique? To achieve accurate measurements, it's important to use the proper method. For example, when measuring the length of a pencil or a sheet of a paper with a ruler, make sure the ruler is aligned correctly. Place it flat against the object, and ensure you are viewing the measurement from eye level to avoid parallax errors. Now, consider the following challenge. How can you accurately measure the thickness of single paper using just a standard ruler? In fact, a ruler isn't precise enough to directly measure something so thin. You can stop the video and try to solve this challenge. Okay, we can overcome this limitation by measuring the thickness of multiple sheets stacked together and then dividing by the number of sheets. This amplifies the tin thickness into a measurable quantity. This example shows how using the right technique can turn a challenging task into something simple. By thinking carefully about how we can approach a problem, we can find efficient solutions that give us accurate results. Sometimes we can choose between refining our technique or upgrading our tools to solve a challenge. In our challenge here, instead of stacking sheets, we can use more precise instruments like vernier calipers and micrometers designed specially for micro measurements. These tools give us even greater accuracy when working with very small dimensions. Now, let's look at what makes measurement reliable. We use two key ideas: accuracy and precision. This tells us how close we are to the true value and how consistent our results are. Let's break this down with an example. Let's think of measurement results like shooting at a target. Here, the bullets are close to the center, showing accurate results, but they are scattered, which means we are missing consistency. Accuracy alone isn't enough for quality measurement. Now, here what we aim for: results that are both accurate and precise. The shoots are not only close to the target, but also grouped together, giving us consistently reliable measurements. Precision without accuracy can happen, as shown here. The bullets are tightly grouped, but they miss the target. Precision alone doesn't guarantee accuracy. Finally, here an example where the shoots are neither accurate nor precise. They are scattered and far from the target, showing poor measurement quality. Now let's look at numerical example. Imagine we are measuring the length of metal rod known to be exactly 10 cm long. Here are 4 sets of measurements illustrating different combinations of accuracy and precision. At first, we have this set with high accuracy and high precision. The numbers are 9.9, 10, 10.1. Then we have this set which have high accuracy and low precision. The numbers are 9.5, 10.5 and 10. Also, we have this set with low accuracy and high precision. The numbers are 10.5, 10.6 and 10.5. And at last, we have this set with low accuracy and low precision. The values for this set are 9, 11 and 10.5. When we take multiple measurements, it's common to calculate the average value, which also called the mean. This is to get more reliable estimate. The average value helps to reduce the impact of random errors and often improves accuracy, especially when precision is low. Now, how we calculate the average? At first, we add up all the measured values, then we divide the sum by the total number of measurements. As practice, let's take set 2 from our previous example. The values for this set are 9.5, 10.5 and 10 centimeters. The sum of these numbers is 30. Then we divide 30 by 3, which is the number of measurements, to get 10 centimeter as average value. Now that we have covered how to measure length, let's move on to measuring the volume of regular shapes. When dealing with regular shapes, we use simple mathematical formulas to calculate the volume. For a cuboid, we use this formula in which the volume equals the length multiplied by the width by the height. For a cube, it's even simpler. The volume equals the side cube. The volume can be measured in different units, like cubic millimeters, cubic centimeters, and cubic meters, depending on the size of the object. Let's look at practical example. Here we have brick with measurements of 215 mm in length, 102.5 mm in width, and 65 mm in height. Using the formula for the volume of a cuboid, we can calculate the volume. This gives us total volume of this number with unit of cubic millimeters. This is how we can measure the volume of regular objects. Next, we will discuss how to measure the volume of irregular shapes which don't have simple dimensions like length, width, or height. For these shapes, we use the displacement method. At first, fill a measuring cylinder with enough water to submerge the object. Make sure to note the initial water volume. Then carefully place the object in the water. After that, observe the new water level and note the difference. This is called the displacement. At last, to find the volume of the object, subtract the initial volume from the final volume. In this image, we can see that the difference between the initial and final levels of water is 30 cubic centimeters. This difference represents the volume of the object. Dear students, by this we reach the end of this video. Keep learning and I will see you in the next one. Till that time, goodbye.